Now, this problem looks a bit hairier. That says x plus log base 10, 1 plus 2 to the power of x is equal to x log base 10, 5 plus log base 10, 6. Now the tip that I will give you to solve such kind of problem, as we can see we have log base 10 everywhere. I'll try to make this x in terms of log base 10. So I can possibly write it as, I can use a formula, or it's actually not the formula, it's a common sense. I know that if I have log base a of a to the power of x, I can write it as x. So I can make x as, according to this formula, log base 10 to the power of x. Actually the thing that I wrote here is actually x. Okay, and here I'll be left with log 10 1 plus 2 to the power of x equals to x multiplied by log base 10 5 plus log base 10 6. Now what I'm going to do next here, I can apply some property on log here that says if I have log of a b plus log of ac, for example, I can write it as log of a b multiplied by c. So applying this property or using this property here, I can sum the two up and the inner things will be multiplied together. So it becomes log of base 10, and the inside things are 10 to the x for the first one, multiplied by 1 plus 2 to the power of x. Okay, similarly I can sum these two things up, but somehow I want to take care of this x first. So what I can do, I know if there's a multiple in front of log, as it is here, I can put it in the power of log. So I can write right side as log base 10 5 to the power of x plus log base 10 6. Now again using the same property here on the right side, so left side stays as it is, log base 10 to the power of x multiplied by 1 plus 2 to the power of x, and on the right I'll be left with log 10 5 to the power of x multiplied by 6. Okay, applying the same property that I applied initially on the left side. Now what I'm going to do, I can easily cancel log 10 on both sides, and on the right I'll be left with 10 to the power of x multiplied by 1 plus 2 to the power of x, and on the on the right here, this log 10 cancels out with the log 10 on the left, and here I'll be left with 5 to the power of x multiplied by 6. Now what I can do, maybe I can write 10 to the power of x as 5 to the power of x and 2 to the power of x, because the factors of 10 are 5 and 2. So I can write it as 5 to the power of x, 2 to the power of x, 1 plus 2 to the power of x, and bringing this 5 to the power of x multiplied by 6 on the left, it becomes minus 5 to the power of x multiplied by 6 equals to 0. Now I can take 5 to the power of x common from both this and this 5 to the power of x. So as I do that, this becomes 5 to the power of x. The inside thing will stay the same. This will be multiplied with this, so it becomes 2 to the power of x, 1 plus 2 to the power of x. Okay, took 5 to the power of x from second. Now that means I'll be left with minus 6 equals to 0. Now I know that either this bracket has to be 0, either the first thing has to be 0, or this bracket has to be 0. But wait a minute, 5 to the power of x can never be 0. You might be saying why? Because 5 to the power of x, if I look at the graph of 5 to the power of x, if I check out the graph of this function, it looks like this. It is actually an exponential function. And we know that the exponential function can take a minimum value of 0, but actually it can never take 0. It actually reaches 0 as it approaches minus infinity on the left. But that's what we are saying. 5 to the power of x can never can never have a value of 0. So this thing is not going to be equal to 0. So the only choice we have, this bracket is going to be 0. So this bracket has the choice to be 0, because this 5 to the x cannot be 0 according to the graph. Okay, now we can see that 2 to the power of x, okay, multiply those two, multiplied by this 2 to the power of x into 2 to the power of x becomes 2 to the power of 2x. Okay, and I can write 2 to the power of 2x as 2 to the power of x squared. Why I'm doing it, you will come to know in just a minute. And here I'll be left with minus 6. So this thing has to be 0. So the next thing that I can do here, I'm gonna let 2 to the power of x as t for a second. So 2 to the power of x is equal to t, and letting t here, so it becomes t plus t square minus 6 is equal to 0. Okay, now what I can do next, I can get the factors here. So what should be the factors? The factors should be t plus 3, right, and t minus 2 should be equal to 0. That means I got two values of t here. I got minus 3 and plus 2. That's actually equal to 2 to the power of x. So simply, what I can write here now, I got two values of t here. T is equal to minus 3 or t is equal to 2. But t itself was equal to 2 to the power of x. I substituted t being 2 to the power of x. So what I can say that 2 to the power of x is equal to minus 3 or 2 to the power of x is equal to 2. But wait a minute, again 2 to the power of x can never be equal to minus 3 because it is an exponential function and its graph will look something like this. Same sketching, if I sketch the graph of this 2 to the power of x, it will look somehow like this. And we know exponential function can never be negative. So neglecting this 2 to the power of x will be minus 3. We won't get any x value from there. And we have 2 to the power of x is equal to 2. From here, exponential function can be positive, so I can take 2. Now taking log on both sides, I'll be left with, if I take log base 2 here, this log base 2 and 2 cancels, I'll be left with x on the left. And on the right, I'll be left with ln of 2, 2. So I'll be like x is equal to 1. So I got x is equal to 1 being the solution for this particular problem.